Okay, in this video, I want to show you how to create a 3D cavity with the transmon inside. The main purpose of this video is also to teach you how to use the HFSS to create some model. It is not straightforward. I have a project open already. This is like my cheat sheet because I want to look at the dimension. But this is not a good one because I don't have variables. So now I'm creating a new one. And then with variables, then you can see how to easily create a structure that you can change its dimension or change the variable easily later, right? So the first thing you want to do is just go to File, New, right? And then I'm going to just expand it and right click. Let me just call it 3D transmon, right? Maybe 3D cavity transmon, for example, right? And then I will go to insert a HFSS simulation, right? It starts with default is terminal network. So what I'm going to do is double click, actually right click, and then check the design properties. No, actually it should be double click. Yeah, solution type. Sorry, I forgot solution type, and then click on eigenmode because I want to do eigenmode analysis. And by the way, if you want to have an overview of it, go back to the previous video that we talk about a 2D transmod, 2D cavity, which is a coplanar waveguide resonator with a transmod, right? We briefly talk about what it is, but we want to do the eigenmode analysis, okay? So I'm done with the setup, right? The first thing I want to do is to create, let me show you what I try to create, right? I also kind of forgot. I go back to this cheat sheet, another parameter. I want to create a superconducting cavity. And then with this here, this is the vacuum inside, right? And then I have a plate here, which is the sapphire. Usually people might then fabricate their Josephson junction, like here. This is the transmon, as I mentioned in another video. This is mostly just for the capacitor because it's a Josephson junction, so you have a huge capacitor. And then this part is to represent the transmon itself. So including, the Josephson junction itself, including the pad and also the aluminum oxide dielectric, right? Because Josephson junction is superconductor, insulator, superconductor. But however, HFSS cannot do superconducting simulation. But we include it just because we are going to assign very huge huge inductance to it to emulate the inductance due to the Josephson junction. Okay, and I just click on Fit All to zoom out. Again, I can zoom in by doing Control plus and Control minus to zoom out. Okay, so what do I want to do? The first thing is like what I'm doing here, right? I'm going to create a perfect conductor, okay? A big box, okay? So this box, I can take a look, the dimension, I will click on this and then right click, properties. I see the dimension is 30, 50, and 30 millimeter, right? So I'm going to go back to the design I'm working on. I will save it, Control S, and then I will just click on this one. We don't need to give the exact coordinate, but I just click on this. Now you have to go on the XY plane first, okay? And then go up. Then you finish the box. And then we will modify it, right? I'm going to right click, this creates box. And then first of all, I'm going to say this is, I have the size, which is, let me call it X mass, right? This is a variable. This time I'm not going to give the exact value. I'm going to create a variable, right? But the value I'm doing now is again 30 millimeter, right? And then I say Y mass. Then I'm going to again 30 millimeter. No, Y mass should be 50, right? I actually want to do 50 millimeter. So now I have a trouble, right? I cannot change here, but I can change it later. 30 millimeter for the Z direction. And this will come from the corner, right? The negative corner. So what I need to do is do negative X mass divided by 2. negative y max divided by 2, negative z max divided by 2, and then I will put the origin 0, 0 at the center of the box. Okay, I say apply, and maybe I did something wrong, but let's see. I say okay, and then just fit all. Yeah, it is looks like correct, right? Now, then I will, I said I did something wrong with the C maximum. So I will go to HFSS, design properties. Then in the maximum, I'm going to change, Y maximum, I'm going to change it to 50 millimeter. Okay, so this is what I have. And you can also go to this orientation, top Z, see if this is, looks like correct, right? It's at the center. Go to the right, yeah. Go to the front, right? I think they it looks correct, right? And then click on this again to have this view. Now this is blocking us, right? So what I'm going to do is double click again, not this one, but go to box, double click again. I want to make it almost transparent, so I will say 95% transparent. Okay, I mean 0.95. Okay, so I can see what was inside, right? And also, this is not the material I have. I'm going to double click, and instead of vacuum, I click on vacuum, and then I will need to do edit, and then I will search for perfect conductor, right? So in the system, you have a material called perfect conductor. You look at the property, it has 1/30 Siemens per meter conductivity. So this is like a perfect conductor, right? I say okay. Okay, with this, I created the perfect conductor everywhere, right? But in reality, in a cavity, I need to create a vacuum. I need to cut it, okay? So what I'm going to do is, again, just repeat what I did, just randomly create a box. I cannot do this. I must do XY plane first, click, and then go up, right? Then I get a box. And again, I don't care about this, where it is. I'm going to modify it. And I remember I want to have 5 millimeter of superconductor. So I was 30, right, the size. So I'm going to add a parameter, let's say called thickness. Okay, so the X size is going to be the X maximum. It let you choose because you already have this. Minus, I'm going to call it the thickness. Okay, then it's going to ask you what is your thickness? 5. Okay. So with this is 25, right? So Y is the same minus thickness, right? And then C is the same minus thickness, right? Now with this, then I should be able to put the position, right? The position will be negative X minus thickness, right? You can define another variable, but I don't do that. Divided by 2, negative Y maximum minus thickness divided by 2, negative Z maximum minus thickness divided by 2. Okay? Right? And it tell you what you get, right? So I just say okay. So is it okay? Looks like it is not okay. It got shifted. So I might have make some mistake. Let me check. The problem is here, right? The minus divided by 2, it should be outside the parenthesis. Because I see this is very large. It's 47. No, it should be 22.5, right? Then I have this inside, right? So let me just go back to my cheat sheet to make sure that is what I have. But looks like this is not the case. Maybe I actually used the another number. Let me take a look. This box. Actually, I have a so actually that is not the thickness, but I think it's okay. I will keep what I have now. It's not exactly the same because the so-called thickness here, what I'm doing is not thickness, it's actually 2 thickness because this is maximum. I should multiply minus this by times 2, right? So that would be better, times 2, right? Because each side you have that much of thickness, right? So I should do this times 2, right? So this is the good thing about having the script. I can change it anytime and pretty easily, right? So I apply to this, now it looks like what I had there, okay? Now with this, you actually have something called vacuum overlapping with the conductor. You need to subtract it, okay? So I'm going to say perfect conductor, vacuum, no, I need to box 1, box 2, and then on the top right, you see here, click again, box 1, control, click the control key, and then box 2, so you select both of them, and then you say subtract, right? Where's the subtract? Here, right? Click on subtract. Now, then it will subtract box 2 from box 1. But remember to say you want to keep count the 2 before operation. Otherwise, box 2 will be gone. Then you even don't have the material called vacuum. Okay? Then it won't simulate in that area. Once I click on this, right, then you see that this one has cloned, right? So you still have this one. And then after subtraction, your box 1 is actually this one, right? And again, I am going to change the transparency of the vacuum to 0.95. Okay, great. So now I created this. Now the next thing I want to do is to create the pot, right? The pot that will lead into the cavity, right? Because now you look at this one actually have a superconducting metal there. So I'm going to create the pot by doing this cylinder, right? So I'm just, again, I randomly click it. It really doesn't matter because I do need to edit it. Now, first of all, this one, it will be, I want to have a pot that I drew a hole, and that hole has to be 2 millimeter. Okay, so this is the radius. Maybe I call this radius. Okay, and that is going to be 2 millimeter. And how about the height? The height should be the thickness, right? And I will start from the top, so the thickness, the height will be the negative of the thickness, so that it will go down, right? But where is the location? Now this location, of course, for the x, I'm going to have 0. I'm going to make it at the center, right? But for the y, where should I put it? Maybe I will put it at, let's say, negative y maximum, remember, minus the thickness. That would be at this region, right? And then let me just call it an offset, something called offset, shift it, right? For example, I can put it by, let's say, 10 millimeter, okay? But you will ask me for the offset later, right? And then for Z, it needs to start from the top, right? So this is the Z max, but divided by 2, right? Okay, so I say 10 millimeter here, right? And see if that works. Apply. It seems that I've made some mistake. Let me just zoom out, fit all to see where it is. Oh, it is really far away, right? We really don't know where it is now. Okay, so what I need to do, just click shift and drag this, and then control plus, or control, actually control equal, not plus, right? And then drag it. So I make a mistake. Let's see, but that should be easy to debug because it gives you the value. You see that this is 9955 millimeter. That is wrong, right? So maybe I put something wrong in my offset, I guess. Maybe you saw it already. What is my offset? It needs to be millimeter. I forgot to put the millimeter. So I'm going to put, it doesn't allow me to do that. So I will just put 0.01. 10 millimeter is 1 cm, right? Yeah. I don't know if I can change the unit. Femto? No. or what I can do, let me see, minute, okay, I don't know why. So there's some problem with this offset, right? So let me go back again, property design. Zero point zero one, okay, and then I fit all, right? So it come to here, but still not the location that I want. That's very, of course, because I should not do, I have y maximum, right, minus offset. I forgot to divide by 2 again. I keep forgetting divided by 2, right? Because this is center is 0, so this is divided by 2. Okay, so let me apply one more time. Divided by 2 minus offset, then I'm at this location. I guess I might screw up the variable. I should not. Let me just call it pot off, right? The offset of the pot. So I think I forgot to choose the correct unit here. I will say this is length. So that's why it's screwed up. And then it's millimeter. I will go to do 10 millimeter. Then I hope that this will look normal now, right? So that is where it is. Okay? Now, sorry for taking so much time. Now, then this one is not vacuum. This is vacuum. I'm sorry. Now, then I need to create another cylinder. Similarly, the goal is to have this cylinder, right? Make it a superconductor at the center. Okay. So what I need to do is actually I want to have exactly the same. I come back to this previous structure. I copy it, and then for cylinder 2, the center position should be exactly the same. The only difference is that the radius is 1 millimeter. Okay, and in terms of the height, it needs to be the same. It should be negative thickness. Okay. Okay. Now, so again, these two are overlap, right? So I need to do a subtraction. But before that, I need to say this one is nothing, but I click on this, and then it is perfect conductor. Okay. So now it goes to perfect conductor. So I'm going to subtract 2 from 1. Right? I'll need to keep it. Subtract 2 from 1. Right? 1 is the big one, right? So with this, then you see that I have the outer part, right? This is a ring, a hollow of vacuum, and then here at the middle is the superconductor, right? Okay. So I want to create another pot. So how do I do that? I can select this, okay, and then I say edit, duplicate a long line. All I try to say is, okay, move this one to here. I want to have something symmetric. Okay, and then I do not do attach to the original object because we might want to modify it separate later. If you attach to it, then they will become one object, and then every time you modify, they will modify together, right? So just say okay, right? So again, this is wrong when I say this duplicate, right? Because I want to move it to the opposite side by so much amount. First of all, in terms of x, it should along 0. In terms of z, it should be along 0. But how about y? How about y? Right? So if you want to make it symmetric, we can do that. But I don't want to make it symmetric because later we might want to move it so that you have different Q factor and also coupling ratio to the qubit. Okay, so this one I will say call it the shift pot, right? I'm going to forget all this later actually, right? Let's shift it by how much? How about by 25 millimeter? And then when you apply, then you get this, right? But you see that someone is lost because we also need to shift this one accordingly. Okay, so this is 0, shift port, right, by 0. Okay, apply. I forgot to give the correct units again. It is again. Okay. So let me go to here, see if I can fix it. Edit. Okay, actually I can load that. I can fix it. This is the length L, and the units is millimeter. Okay. And then if I apply, then it will come back, right? So this one is shift a little bit too much to the edge, but that's okay. We are just doing some testing, right? And again, we have two different quantity, right? The middle one is the superconductor. This one is the vacuum. It has nothing, right? Now, for the future, we might want to do some analysis, use scattering matrix analysis. So I want to also to create a disk here, okay, along here, so we can add the boundary condition. Okay, so let me go ahead to draw a circle. Right, the circle should be at the center and then covering the whole thing, right? And this sheet again, it needs to be no, that is okay. Do that later, right? So I create this center. Again, this center, I want to use the same center as this cylinder. So I click on this, create cylinder, and then I want to copy this one, right? I don't want to it to got shifted in the future. So I delete it. Radius is still 2, right? I can keep it as 2. This is easy to change, so I keep it as 2. Then, or actually, do I have do I have any variables so far? Yeah, so okay, I actually forgot that I have a variable, not here. So actually, I would like to change the variable. If you look at the cylinder 2, I do have this vacuum cylinder 1, right? We do have a variable which is called radius, right? And actually, I feel that I should, for cylinder 2, I should use a variable also. I call it radius 1. How about I call it radius 1, right? And this will be 1 millimeter, okay? Right, this is just make things easier. So here I'm going to use radius, just call radius because it's outer one, radius. Okay, so I have this. I click on this. I do have a big circle, right? And again, I need to subtract it because I only want it to be the outer region. So just as a practice, so I click on this and then create another one like this, right? So again, I need to copy all these things to make things easier. So it's good to have a cheat sheet or something. You wrote it down when you're drawing this to save you time, right? And this, I call it radius 1. Okay, so why do I want to do this? The goal is because I want to subtract it. So I'm going to click on this one and then this one, remember? Actually, how to click it? This one, yeah. Click on circle 1, circle 2, and then I say subtract. Now this time I don't want to clone it because the middle one is useless to me. So I just click on this, right? Then now I have just this ring. Okay. Now with this ring, what do I want to do? I'm trying to assign a boundary condition to it. I click on this and go to the boundary. Okay, not this structure. We're doing this one, right? Right click. We say assign Lumped LRC, and then we are going to assign 50 ohm, right? Because most of the microwave circuit use 50 ohm. But then you need to define a 9, okay? So I can do control equal to zoom in, and then still can do shift drag to move it. And then the 9 will come from this edge to this edge. Click on this, just do double click, right? Click 2 times, not double click. Each one is single click, right? So with this, if you click on the boundary, you will see that this one has a lump LC boundary 50 ohm. Okay, now I want to do the same thing for the other one, right? But you know how to do it. Remember this duplicate a long line? I want to duplicate this, right? So all I need to do is just click on this lump LC, right? And then I say edit, duplicate a long line. I will just move it to somewhere, right? And then I don't attach it, just 2. And then for this duplicator one, I click on this. Or I can just click on this one actually, right? And then I will try to modify it and copy and paste what I just did now. Say OK. Now, if you then zoom fit all, you will see that I have the circle 1 here, circle 2 here, right? At the same time, I have 2 boundary condition, right? Okay, so this basically completed the cavity. Okay, and then maybe I want to break it into 2 videos. Then the next one, I will show you how to insert the sapphire and the Josephson junction qubit.